You know, when you're in a hospital, you're surrounded by all this technology, monitors, sensors, pumps, but have you ever really stopped to think about the incredible, invisible journey those devices take before they're even allowed in the room? Well, today, we're going to pull back the curtain on that safety machine and see exactly how it all works. At its core, getting a medical device approved is kind of like running a super complex machine. Every single gear you see here, that's a test, a document, or a standard. And if just one of those gears fails to turn perfectly, the whole system can break down, putting people at risk. The goal here is perfection, or as close as we can possibly get, because patient safety is the only thing that machine is designed to produce. All right, so here's our roadmap for today. We'll start with the big idea of the safety machine itself. Then we'll get into the actual rulebook that everyone has to follow. After that, we'll run through the testing gauntlet, check out the paper trail of proof, and finally, we'll talk about why this whole thing matters so much to every single one of us. Okay, let's dive in with the big picture, the safety machine. And this isn't just about ticking boxes on a checklist. It's a whole philosophy, and it's all built around one thing: protecting patients. This right here is the absolute core mission. I mean, from a simple sensor that clips on your finger to some massive, complex life support system, every single one has to prove that it not only works, but more importantly, that it is fundamentally safe. That's it. It's the non-negotiable #1 rule of medical tech. So, how do you make sure this whole process is consistent and trustworthy all over the world? Well, it all starts with a shared rulebook. This isn't some free-for-all where companies make up their own rules. Nope. There are strict, internationally agreed-upon standards that every single manufacturer has to follow. And this right here, this is the big one, ISO IEC 60601-1. Now, it sounds super technical, and, well, it is, but you can just think of it as the global gold standard. It covers literally everything, from making sure you don't get an electrical shock to checking if the device can survive being dropped. The key thing to remember is that this standard means a device made in one country has to meet the exact same safety rules as one made on the other side of the planet. Yeah, to put it simply, if you want to build and sell a medical device, you have to play by these rules. It's like this shared language of safety for the entire medical tech world, and it makes sure everyone is held to the same incredibly high standard. All right, so we have the rules. Now it's time to actually put the device to the test. Literally. This is where it enters what we call the testing gauntlet, which is basically a series of tough challenges designed to prove it can actually do what it claims to do safely. So this gauntlet has a few key stages. First, the machine is installed and tested right away to make sure it's working properly from the jump. Then comes the in-house testing, where the creators check their own work with a fine-tooth comb. Next, it gets calibrated for absolute precision. And finally, maintenance reports are created to prove it can stay safe and effective for its entire lifespan. Now, what's really key here is who does the testing. You've got the in-house stuff, which is kind of like the manufacturer checking their own homework. It's super important for quality control. But then you have the certificate from a subcontractor. That is like the teacher grading the final exam. It's an independent, unbiased third-party lab that verifies everything. You absolutely need both to have a system you can trust. You know, running all these tests is one thing, but proving you actually did them, and that you passed, is a whole other ballgame. That's why every single step in this process creates a document. It all adds up to an undeniable paper trail of proof. And this trail starts with something called the medical device file, which is basically the device's entire life story. Then you have all the specific reports for performance, safety, calibration, maintenance, you name it. All this evidence builds and builds until you get the final prize, the certificate, which is the official stamp of approval saying, yep, this device is ready to go. And this is what that paper trail actually looks like. This is page 1 from a real official test report. It's not a flashy marketing brochure, right? It's dense, it's technical, and it is incredibly serious. This is the hard evidence. Okay, so you look at a document like that, and it can be a little intimidating. So let's break it down. What is this piece of paper actually telling us? What does it prove? This table really makes it simple. The standard section, that confirms they've followed the official rulebook we just talked about, IEC 6061-1. The applicant tells you exactly which company is responsible. Test item gets super specific about the exact model, in this case, a multi-parameter PSG sensor. And then you get to the most important part, the result. That's the final verdict. the pass or fail, on whether it meets all those critical safety and performance rules. So we've looked at the machine, the rulebook, the tests, the paperwork. It's a lot. But why do we go through all this trouble? Well, the answer is actually really simple. It's about people. I think this quote just nails it. It perfectly captures the whole philosophy. A company might build a physical thing, a device, but the real product they're delivering to the world, the thing that truly matters, is the promise of patient safety. And really, that's the ultimate takeaway here. This entire complex, often invisible system exists for one reason: to give all of us confidence. It's there to make sure that the very technology designed to help us and heal us has been proven, beyond a shadow of a doubt, to be safe and reliable when we need it the most. It really leaves you with a final thought, doesn't it? We just unpacked this one massive, hidden safety system. But what about all the others? From the food you eat to the car you drive, what other invisible safety machines are working tirelessly right now behind the scenes to protect you every single day?